idea of grade, you are using what I like to call a subset of similar triangles. I mean, if you think about it, we skirted around that idea by saying, back in the day, it doesn't matter what unit you use as long as you're consistent. I don't care if you're talking about a 6% grade, if it's feet, inches, miles, kilometers, whatever you want to use as long as you're consistent. And that's the notion of a similar triangle. I don't care if it's 4 over 11 feet or 4 over 11 inches or 4 over 11 yards or 4 over 11 miles. Doesn't matter. Or 4 over 11 millimeters. Doesn't matter. It's the same ratio because the units are going to cancel off. We have a project devoted to units in week 6. Not till week 6. Way out there, way out there. Okay. So, help me. How do we deal with this? How do we deal with this situation right here? What do we do? Help me, help me, help me. We have to derive something to figure out what that's something we're doing a run, I guess, if we're at the bottom. Tell me your name again.
Marichelle.
Marichelle, if you don't mind, go ahead.
You would do 4 over 11.
Okay.
60 over X.
60 over X. Let's make sure we understand that and buy it. So Marichelle says 4 over 11 is the same as 60 over X. So first of all, Marichelle, how do you know how to do that? Of course, I asked you a question. You take a drink. I apologize.
Just because of the short sides correspond to each other and the long sides.
Good! So this is why I made a big deal out when Jerry put the little boop, boop, those little dots there. That means you got corresponding angles. And therefore, we know this 4 corresponds to that 60. So Marichelle put the 4 here and the 60 here. Love it. She also put the 11 here and the X here because those have to correspond as well. Did anybody have a different equation they came up with in the beginning? Christine, can I come back to you? Is that okay? Because I like to solve it 2 ways. At least 2 ways, if that's okay. And just to show you guys that there is not going to be one solution method always. That's totally fine. We'll come back if you don't mind. If you don't mind. So this kept the 2 sides of one triangle to the 2 sides of the second. All right, Josh, help me out.
Another way you can do it is...
Oh, can you hold that? Just hold that. I want to get other ways too. Let's finish this one off first.
Oh.
And then I do want to do other ways, for sure. I like seeing multiple solution paths because then you guys can pick the one you like the best. So we'll call this one solution path A. And we'll finish her off. Who wants to finish us off? What do you think? Is it
Josh.
Josh? Oh, Josh. Good, Josh. Go.
You cross multiply.
Tell me what that means.
You multiply the X times the 4 and the 11 times the 60.
That is absolutely one of the ways to solve. This is called proportion, right? A proportion is a fraction equals a fraction. And how many remember cross multiplication? Good. As long as you have a pure proportion, this totally works. I'm going to put this down here. 4 times X equals 11 times 60. With your permission, if it's okay, I'd rather not multiply that out and get 660. Can I divide by 4 right now to get rid of that 4? And the reason I can choose to do that now is because it's easier to divide 4 into 60 than 4 into 660, if that's okay with you guys. So if I divide that off and divide that, I get 15, and now I get 150 plus 15, 165? Did I do that right? So I don't know what 165 it is. 165 feet, 165 inches, doesn't matter to me. It's 165 of whatever it is. All right, it might be as big as your thumb, might be as big as a building, but it's 165. And Christine, yes, Christine, I thought of your triangle for a moment there. I'm assuming you would have used the triangle, right?
Yes.
Remember Christy's triangle from last week? When we have proportions like this, it's actually exactly the same as what we just did, if you think about it. She would say, draw a triangle around the numbers you know, and multiply the diagonal, 60 times 11, and divide by 4. And if you think about that, that's what we just did. Just in 2 steps versus 1. So, either way works. Love it. Any questions about solution method A, which is great. It's fantastic. Decent, fair? So, let me hear, I got a feeling Josh and Christina have the same, maybe the same solution for B. Let's hear the alternate way of doing this one. Go ahead. Yeah.
Oh.
Let's hear it.
I did 60 divided by 4 in parentheses times 11.
And why did that work?
Because it gave me 165.
Because it gave you 165. Suppose we didn't have this in front of us. How'd you know you had the right answer? What is that based off of? I love it, Christina. I love it.
I can't remember.
It's okay. So here, if you look at Marichelle's way, she went 4 to 11. So what she did was she said short side in one triangle to long side in another triangle. So if you don't mind, I'm going to write that up here. So this is short side triangle 1 to long side triangle 1. Must be the same as the short side in triangle 2 to the long side in triangle 2. And that's if you think about it, that's what Baruchel's solution is based off of. So focusing on one triangle with one fraction, focusing on the other triangle with the other fraction. Perfect. Christina, yours focuses not on just triangle 1 in one fraction and triangle 2 in the other. You actually put both triangles together in each fraction. You put the short side in triangle 2 and compare it to the short side in triangle 1. And then you compare that to the long side in triangle 2 to the long side in triangle 1. So when you said 60 to 4...
That's why I was getting confused, though.
Say that again?
When I was doing it, I was getting confused when I got down to the lower one.
That's okay, because we'll come back to that. Because what you can do is you can actually turn them into this case.
Right.
And see them. It's just when you're sitting on top of each other, sometimes it's hard to
I just
see.
had to go to tutoring center to figure
That's
it out.
okay. That's okay too. Amy, what's on your mind?
What I was thinking is that one is just that one flipped with
Yes.
numbers.
Yes.
Laid on
And
top.
see, that's what I like to hear in mathematics classes, when you are able to look at 3 different exercises and say, wait a minute, these aren't 3 different. They're the same exercise. All he's done is he's taken one triangle and flipped it around. Now, why would he do that? Is he a bastard? We'll talk about why I do that in a second. Or why I would nestle one on top of each other in a second. There's reasons for all of this. But the fact that they're all the same problem, that's the important thing to focus on. Good. So when you see this, you end up with, what's that, 60 over 4, I think I did this right, equals x over 11. If I substitute it incorrectly. Now take a look at that equation, and take a look at the one we had over here. Yes, take a look at them. What do you notice? That one's easy? Oh, why is it easy? Listen, I wasn't expecting that.
Same one.
That's what I was looking for. It's the same. Now, I think maybe easy is because the x is up top versus at the bottom. That might make it easier to process because the x is already in the top of the fraction. Maybe. But it's the same equation, isn't it? If you think about it, it's the same exact equation. Look at the diagonals. 60 and 11 are on a diagonal. 60 and 11 on a diagonal. 4 and x on a diagonal. 4 and x on a diagonal. If you did the cross multiplication that you guys mentioned before, you'd get right to here, wouldn't you? You'd actually get to the exact same equation. If we use the triangle, we get the exact same expression. So they are the same solution. I mean, we can call them B and A because of this. But even if you look at this and this, if you swap out one diagonal, which is totally legit to do algebraically, as you remember from math, whatever, if you swap a diagonal, you get the other equation. It's the same equation, just written 2 different ways. Josh, this is the way you did it, I'm assuming? Exactly, and it works brilliantly. Absolutely. Oh, and we did it a third way.
Completely different.
Tell me how you did it.
It's hard to explain.
Well, here, do it then.
Take a look.
Here, you want to do it?
I don't know.
No. 411. Oh,
And
percentage.
then I went down through here to get the.
Holy crap.
165.
Spend more time.
No. This is.
It's
She
insane.
used the same idea. No, it's not insane. It's not insane at all. She used the idea of a scale factor. The idea of a scale factor. So what she said was 4 to 11 is roughly, let me see, 1 11 is about 9%. Or yeah, about 0.09. If you divide 1 by 11, it's about 0.09. So 4 divided by 11 is about 0.36 or 36%. I happen to see that written down on your paper there. So she said this side to this side is roughly 36%. So this side to this side has to be roughly 36%. You somehow got the hypotenuses involved, which is adorable because you don't need them.
Oh, I don't know.
But that's okay. That's okay. Your equation, believe it or not, at heart, 60 to x is about equal to that 0.36. That's the same equation as this, because this is 0.36. So at the heart of your argument, you have the exact same equation too. You just chose to use a decimal instead and get the hypotenuses involved.
And the hypotenuse.
Which was
yeah,
fun.
The whole thing.
It looks like you applied the percentage to the hypotenuse, got that value in the reverse engineered.
Yes, exactly.
It's cool. Nobody says you have to go A, B.
I wish
Nobody
I
says
figured this
that's
out. This is
okay.
what you
Well,
did.
let's see if we can apply it to the other two.
Okay.
Let's see if we can see how this, as Amy pointed out, these are all the same problem. Let's see if we can see how they're all the same problem, because they are. That is crucial. And hopefully you realize how precious little mathematics we actually did here, right? Very little tiny bit of mathematics. This is where I think algebra classes lose it. They make us focus on so many disparate pieces. I like to focus on how things are the same and how all these are the same. Good. Any further solutions on A, B, C, maybe a D over here? We happy with it? I shouldn't say happy. We content with it? Nobody's truly happy in math class, except me. Let's back this out. All right, so now we're here. Whoops. All right, so now, speaking of which, let me give you application.